To draw a beam in SAP, we first need to go in File and select New Model. Make sure you're working with the right units. Here in the example, we're using kip and feet. Afterwards, you have to select the right template. Here we're going to use grid only. This feature allows us to select the number of grid lines along with their spacings. Given that the beam is in one dimension, we don't need to use many grid lines in the Y and Z directions. So here I'm going to reduce the grid lines to only one. And I will press OK. On the left window, you have the two-dimensional view. On the right window, the three-dimensional view. SAP2000 likes to use the Z-axis as the vertical axis. We're going to keep this feature here. Click on the left window and look at the XZ plane. Here you can see the grid line that you have created earlier. Now it's time to draw our beam. We're going to select Draw Frame here on the left-hand side. Click at 0 and then finish the beam at x equal 30 feet. You can also see the coordinate system in the bottom right of the window. Once you're done, you can double click to get out of the selection or simply press escape. Now we will add the supports, the hinge and the roller. To add a support, you click Add a node, select Assign, Joint, Restraints. In this case, we have a hinge. We can simply click on the hinge or simply ensure that all the translations are restrained. Here, translation 1 corresponds to the local x-axis, 2 to the y-axis, and 3 to the z-axis. We do the same thing for the roller. Click on the joint, assign, joint, restrain, and here we put a roller. Notice that the roller here is restrained only in the z direction. If you were to work in the xy plane, then you would need to only restrain in the y direction. But this is not our case, so we keep with the z direction here. Now that we have a simply supported beam, what we would like to do is ignore self-weight in our analysis. So we're going to go in Define, Load Patterns, and remove the self-weight multiplier. Put 0 and click Modify Load Pattern. Now we need to add our distributed load. To add a load on a beam, you have to click on the frame, then assign frame loads, and in our case, we're using a distributed load. You can select the axis along which you're going to apply the load. In this case, I'm going to use the Z direction, but you can also use gravity if you want. Our load goes downwards, so -5, and use the right units here, -5 kips per foot. And here you have your beam spanning 30 feet with a distributed load of 5 kip per foot. Now that we are done drawing our beam with the distributed load, we can analyze the system. To analyze the beam, you can click the arrow here or simply go in Analyze, Run Analysis. You first need to select the load types, but we have not defined any. So you can simply click Run now. And this is our beam. The right hand side here is showing the deflection shape. If you want to show the deflection shape on the left, you can click on the left window, go in Display, Show Deform Shape, click OK. You can also play the animation of the deflection shape. Here what we want to do is verify the maximum moment in the beam. To verify the moment in the beam, we can display the forces acting on the frame. Here I'm going to select the moment in the 3-3 direction, and I have the moment drawn on the beam. To see the values of the moment, you have to right click on the frame, and here you have all the forces acting on the beam. The shear force, the moment, also values for deflection. To get the value of the moments, you have to slide the line along the axis of the beam and look at the readings here on the right hand side. However, this is much easier if you have a node right in the middle of the beam. To do so, we need to unlock the model first to modify it. Now if you click the beam, you see that the beam is spanning the entire grid lines and there's no node in the middle. We can add a node by dividing the beam into 2 sections. To do so, we go in Edit, Edit Lines, and Divide Frames. Here we have several options. What we want to do is divide the frame into 2 sections. And here you see you have a node in the middle. If you want to see the nodes, you can go in View, Set Display Options, and uncheck Invisible Joints. Here we have the nodes showing on the left-hand side, middle, and the right. We can rerun the analysis and right-click on a frame, and you can see the maximum moment here is attained on the right-hand side where the center node is. In this case, the maximum moment is 562.5 kip feet, which is consistent with theory.